Today we'll be learning about scientific notation. And what scientific notation is it's a way of writing very large or very small numbers. You don't need to write these down, that's why it's on my sticky note. But what I mean by large and small numbers, 11 billion, that would be a very large number. Or maybe 11 billionths. Would be a very small number because it's, if you notice, the whole number is only a zero, so it's a very small number. So scientific notation is a way that we can compact these numbers and write them a little bit smaller. You don't have to write the zeros every time. So that's the first thing we're going to put in our notes, that a compact way of writing very large or very small numbers. So a compact way of writing very large or very small numbers. Remember, if I go too fast for you at any time, please just pause the video, write down what you need to, and then continue working. So we have those, like we said, very large numbers or very small numbers. Either way, they're numbers that usually have a lot of zeros. So our job in scientific notation is to get rid of the zeros. So what we're going to work on first is we are going to focus on how to turn from standard form into scientific notation. And standard is what you're used to seeing, numbers written like this. These are standard form. So what I want to label here is standard form to scientific notation, and I'm actually just going to abbreviate that with SN for scientific notation. Remember, you can always pause and write down and then continue listening. So I like to color coordinate my notes. I'm going to use, for this particular lesson, I'm going to use blue and pink. You do not have to color coordinate your notes, but if you are interested, those are the two colors I will be using throughout this video. So the first step we have when we want to turn a number from standard form to scientific notation, the first thing we need to do is put the decimal behind the first number that is not a zero. So put the decimal, because every number has a decimal, whether we see it or not. So put the decimal behind the first number that is not a zero. The first number that is not a zero. And by not the first number that's not a zero, think about how we read. We read from left to right. So if I was looking at the word decimal, right here is behind the D. If I was looking at the word put, right here is behind the P. The period is behind the O and zero. So remember when I say behind that we read left to right. So we read from left to right. So that's step one. You put the decimal behind the first number that is not a zero. And I did that in blue. I'm now on step number 2. Step 2 says count how many times the decimal moves. And this is going to be very important. And the reason this is going to be important is this is going to end up being our exponent. This is going to be the part of our scientific notation that tells us how big the number is. So this is the exponent. Now I know I've said it a couple times, but I'll keep saying it. If you need to pause the video, finish writing down, do that before you continue on. So I need you to get a highlighter. I like to highlight the things on the paper. I do not highlight everything just for the sake of highlighting, but we want to be able to highlight the things that are actually important, that when I open this note page, these are the things I want to stand out. So I'm going to highlight both of these steps. These are the things I want to be able to see when I open up the page. We are going to do a couple of examples now together. And look at this. Remember, if you have problems at any point and you're like, I don't understand it throughout the example, just pause and slip up your hand, or go back and re-watch what I did, and that might explain it if you see it a couple times. So the first number we're going to deal with, we are going to do 35 million. I'm going to go ahead and put in equals, because over on this other side I'm going to put it in scientific notation. Now, step number 1, my blue step, so I'm using my blue pen, said put the decimal behind the first number that's not a 0. And I told us, remember, we read from left to right. So if I start right here at the left and I'm going right, the first number I come to that's not a 0 is the 3. So this tells me I need to put a decimal behind that 3. And that's all I need to do for step 1. Now step 2 said count how many times the decimal moves. You're probably thinking, what on earth? I don't know what you mean by moves. Well, every number, if you can't see the decimal when you start, it was at the very end. So any whole number, there's a decimal at the end. So when we count moving, we count how many times it had to, how many numbers it had to move. So I do that using loops. So if I go around this number, that's 1, 2, 3. Now be careful, the comma does not count. So far we've moved 3 times. Around this number's 4, 5, 6. Once again, be careful, the comma doesn't count. 7. I moved my decimal 7 times to get it from where it started at the end to the new place. And this is going to be important, where my decimal is now and where my 7 is. Because remember, scientific notation is supposed to be compact. We're trying to make this number smaller. To do that, we are going to keep these numbers right here next to the decimal, the things that are not zeros, this 3.5. We are going to times it. The cool thing about scientific notation is it is always times 10. And then our exponent. I told you up here that the exponent is how many times we moved it, and our exponent is going to be a positive 7. I used to always tell my students, and I'm going to tell you, I think positive because it's a big number. Had it been a little number, we would do negative, and we're actually going to do one or a few like that here in a few minutes. So let's look at another number. Let's do 702,000. Because this one's a little bit tricky because it does have a 0 in the middle of it. But I still can follow my 2 rules. Remember, pause if I'm going too fast for you. Rule number 1 said put the decimal behind the first number that's not a 0. Well, I read left to right. So the first number I come to that's not a 0 is a 7. So I'm going to put that decimal right there. Now the second thing says count how many times the decimal moves. Now remember, our decimal was here at the end, so when it's moving, we're going around the numbers. 1, 2, 3, don't worry about the comma, 4, 5 times it moved. So I'm going to write that here. Because I now have the information I need to put this into scientific notation. Now up here, we were able to get rid of all the zeros because they were at the end of the number. If you notice, this one has a 0 in between 2 regular numbers. So we have to keep it. So when I come over here, I'm going to write 7.02. We always times it by 10. And remember, we have a big number and we moved it 5, so it would be a positive 5. We're now going to look at some small numbers. So by small, I'm going to put 0 decimal, and then I'm going to put 6 zeros. 1, 2, 3, 4, 5, 6, 67. And we're also going to put this into scientific notation. Are going to follow the exact same two rules. So rule number 1 said put the decimal behind the first number that's not a 0. And I read left to right. So I'm going to start at the left and go over. 0, 0, I'm still at zeros. Oh, the first number I come to is a 6, and I'm putting it behind the 6. So behind it's going to be right here because I read left to right. So step 1's done. Step 2, count how many times the decimal moves. Now up here we didn't see a decimal, so we knew it was at the back. Well, down here we know where that decimal was to start, so we need to count how many times we had to move it to get over there. So let's see. 1, 2, 3, 4, 5, 6, 7. And I'm going to draw an arrow so I know which direction I moved it. I'm going to write the number 7, but I'm going to go ahead and make this a negative. Negatives are what are used when we have small numbers, and in this case this was a small number to begin with. It's less than 0. So now when I go to write this in scientific notation, I can get rid of all those zeros because they're just out there. They're not near our decimal or between two big numbers or two regular numbers. So we have 6 decimal 7. It's always going to be times 10. And I moved it 7 times, and I'm going to make it a negative because it's a small number. So negative 7. Remember, pause if you need to. Rewatch it if you didn't understand. We're going to do one more together. I'm going to do 0 decimal, and this time I'm going to do 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 6. I'm going to use my same two rules that we've already talked about up top. So the first rule, remember, said put the decimal behind the first number that's not a 0. And that first number I come to that's not a 0, let's see, I'm reading left to right, 0, 0, zeros, all these are 0. Oh, 9 is the first one I come to, so right behind the 9, I'm going to put a decimal. Step number 2 stays the same. It says count how many times the decimal moved. Well, we can see where this one started, so I just need to count how many numbers it went around. 1, 2, 3, 4, 5, 6, 7, 8, 9. I draw an arrow so I know which direction I moved. So I'm going to go ahead and write a 9. I want you to start thinking, was this a big or a small number to start with? Hopefully you're thinking small, which means this is going to become a negative 9. Negative just means small. Now this is one of those special rules, kind of like the 702 up here. We can't get rid of this 0 that's in between the 9 and the 6. We have to keep it. We can get rid of all these other ones because they're just out there, but when we go to write it, we have to write 9 and 600ths. It's always going to be times 10, and our exponent is negative 9. At this point, you should have the example problems out of the crate, and we're going to go ahead and glue the first set of example problems in the bottom. So you should have glued in the ones that are numbered 1 through 10. They were labeled as standard form to scientific notation notes. And you're going to do the exact same thing we've been practicing. You're going to do step 1, put the decimal behind the first number that is not a 0. So you're going to look here and determine what's your first number that's not a 0. Remember, we read left to right, so it's going to be the 8. And the second step, we're going to do the same thing we did up top. We're going to count how many times the decimal moves. Remember, if it's a large number, we don't know, we can't see the decimal. We know it starts at the end, so we're going to move 1, 2, 3, 4, 5. And I can keep it a positive because it is a large number. So my answer would be 8.45. I can only get rid of zeros. I can't get rid of the other things. Always times 10, and it's a positive 5. You will need to complete the rest of these and get them checked by your teacher.